Hello friends, in last session we have seen one use of this keyword, which is to refer the instance variables, and in this we are going to see the another use of this keyword, and that is to call a method. To call a method you can use this keyword, right? And how it is: suppose you have a class ABC, and in that you have, say, one method void m method, right? And here you are getting one SOP statement, say m1 method in ABC, right? Then you have one more method, say void m2, and then you have SOP statement m2 method in ABC, right? This, and so currently till this, right? Now you have class test. Assume you have class test, and in test class test, in that you have main method void main. Inside the main method you have one ABC object, a1 is, say, new ABC, right? And on that a1 you are saying a1 dot m1, and you are saying a2 dot m2, right? Now if you execute this test, then how it works in JVM, right? Say you have, this is your JVM, suppose. Right, in this you have the method area, stack, and heap, right? So first test class is loaded, this is test, and then you have here the main method. Inside the main method you have a1 reference variable, which is pointing to this object, and the object address is a 1040, this is 1040. Now when we will say a1 dot m1, when we will call a1 dot m1, then m1 methods loaded inside the stack frame, in another stack frame. So this is m1, right? And here you have the SOP statement, it has to print here m1 method in ABC and all, right? a1 method in ABC. When you call like this, then it prints this here in the console, or in the IDE. So it prints here m1 in ABC, right? Once the execution of m1 function is over, when the execution of m1 function is over, control comes back, means this statement execution is over, and it is going to execute this now. When control comes back, immediately this stack frame is going to be destroyed, and the memory is free now, right? And it is cleaned. So it is, so this is not here now, this is deleted, output is given, and the stack frame is destroyed. Now you have this next statement, a1 dot m2 again, right? Now on top of this again another stack frame is generated, and here it is m2, and m2 is having a SOP statement, prints m2 in ABC, right? So the output here, it is now m2 in ABC, right? Then this stack frame is, from here again control returns back to the main method, and this stack frame is destroyed, and this is also destroyed, right? So this is the output for this test. Output is M1, M2. For the execution flow, once the M1 function was loaded in the stack memory in a frame, and that was destroyed, and after that again you called M2, then M2 is loaded in the stack memory again, that is also destroyed, right? But if I make it like this, suppose this M2 function I will not call from here, okay? M2 function I will not call from here. This statement is not available in this, and now M2 I am calling from M1 function, okay? So this is M2. From M1 I am calling M2. Now how the output is? Now what will happen is, say I'll start from the beginning. This is not here. Right. Now this is the memory, and in this, say you have a first when you will execute test is loaded, okay? Then this is main method. Inside the main method you are creating a A1 reference variable, so this is A1, and A1 points to an object. This is the object. The address is 1060, assume, so this is 1060, right? When I say here A1 dot M1, then M1 gets loaded, right? And in this is M1. This is M1. Right, so this is M1. M1 is loaded. Now when we'll call like this, from this actually control goes to M2 function, right? So this is not M2 from it goes to M1 function. So this is M1, and inside the M1 statements you have, first statement is M2 is to call, right? So first statement is this is M2. Now because you are calling M2 from this location, so control comes into M2 now. So the M2 should be loaded on top of this stack frame. One more stack frame is generated, and here it is M2. Now control is inside this, and it prints here first statement M2. Now the output is M2 in ABC. Now no other statement is there, so control returns back into this location, then it goes to the next statement of M1. When this statement here it is over, it is printing here M2 in ABC. When this statement execution is over, then control comes back to this location. Now here the second statement is SOP statement of M1 in ABC. Right, now it prints here M1 function in ABC, right? This is ABC. Right. When this execution is also over, control comes back into this, and the complete execution is over. This is destroyed, this is destroyed, this is also destroyed, and that memory is returned back to the operating system, and JVM is terminated, right? But now here you have to notice, previously what we did, we have called M2 on A1 object, right? A1 object separately, differently. But now what we did, we have called M1 function from the main method, and from M1 we have called M2. But actually it is the same thing, right? Only difference is previously M1 M1 method was loaded in the stack, and a stack frame was generated, then it was destroyed, then M2 is called, and M2 stack frame is generated, then that is destroyed. But now how it works, first M2 is loaded, M2 is not destroyed. Before that only M1 was loaded. First M1 was loaded, then on that M2 is loaded before destroying the M1, and M2 method is here. Then M2 is destroyed, then control came back to M1, and from there control again came back to main method, right? So this is the difference. But in both the cases, here you had this keyword which was pointing 1060, it was here, and here also you had this keyword, this was also pointing to this in both the cases, right? Now you can say here, when you say a1 dot m1, m1 is a function is an action. The action should be performed on a1 object, right? A1 is pointing. When you say here a1 dot m1, what is the meaning? m1 function you are calling on a1 object. a1 is a reference variable which is pointing to an object. So by saying this statement a1 dot m1, m1 is a function and function is an action. So m1 action is applied on this object. Again, when you say a1 dot m2, then m2 action is applied on this object, right? It is like this. But when you are calling this m1 and m2 in previous case in this way, then both m1 and m2 you are calling from the reference variable which is available inside the main method, which is available inside the main method. Now when you are telling here m2 from m1 function, actually it is not m2 dot m1, it is actually, or you can say it is like this. So we'll take one more example. Say I have class ABC again, and an ABC void m1 function, right? And in that one SOP statement m1 in ABC, and you have void m2 function, and this is SOP statement m2 in ABC, right? Now class test. In test you have the main method, public static void and main method. Inside the main you are creating an ABC type. A1 is equal to new ABC, and this is a1 dot m1. When you call m1, m1 has to call this dot m2 like this. So if you are not mentioning here this currently, it is not exactly no difference, it is automatically take this dot m2. Now in this the memory allocation is so you have this is method area, stack and heap, right? So test class is loaded, this is test. Inside this here main method is loaded, and a1 reference variable which points to this object 1020, this is 1020, right? Now when we will say a1 dot m1, then on top of this main one m1 method get loaded. So this is m1, and here you have this keyword, right? And this points 1020, this is pointing here. So this is loaded. Now control, when you will say here a1 dot m1, m1 is called, and it is first statement. Now first statement you have written here this dot m2. Now this means when you will say here a1 dot m1 means what? A1 is pointing to this object, on this object you have applied m1, right? Now after doing this action when it is applying, m1 action when it is applying on this object, m1 gets loaded, and inside the m1 you have this which is again pointing to the same object, and again on this you are telling m2, means on the same object again you are applying m2, right? So what will happen, on top of this again m2 gets loaded So this is m2. Inside m2 again you have a this, which again points to the same object 1020. This is also pointing to this, right? Now control is from here, control came into this m2 and it is inside the first statement. So here it prints m2 in ABC, right? Now no other statement is available in m2, so control goes back from here it came, and then in the next statement of m1, so it is coming back here from where it gone, and this is destroyed. Now when it is destroyed, okay, this is destroyed and control came back. So in this now you have the statement here m1 function in ABC, right? So this is going to be executed, and the output here you can say m2 in ABC and m1 in ABC, right? Now this execution is over, so then control also comes back from here, and from here it comes back to this location, and that is also destroyed. Both the memory is destroyed. Now control is inside the main, and main is not having any other statement, and that is also destroyed, and total memory is returned back to the operating system, right? And JVM is terminated. So the thing is, here with this keyword you are calling m2, but currently if I don't use this keyword, if I just say m2, then also it is actually this dot m2. So here this is the another use of this keyword. To call a method from another method, you can use this keyword. Currently in this case, if you are not using this keyword, then also it works in the same way automatically. But in the inner class, when we will discuss inner class, in the inner class topic, you can see that in the video that in the inner class, in some cases you have to use this keyword to call a method from another method, otherwise it gives some different results and calls some other methods, right? So this is the another use of this keyword, to call a method from another method, right? Now let's see that with an example again. So go to the IDE and take a test. So this is test 1 again, and this is com.p10. Main method is there, and in that, so you have class ABC, and in that void m1 is a function, right? In that you are printing m1 function in this is ABC, right? And then you have m2 also, m2, and in this again m2 function in ABC, right? Simple. Now in this you take ABC A1, new ABC, and A1 dot M1 or A1 dot M2, right? If you call like this, then M1 in ABC and M2 in ABC, right? Run it. It is this, but the execution has a difference, right? We have seen how actually it works with the memory when you say like this. Now it is not this one, and from here you call M2. For here you call M2, right? Now you run it, and the output is M2 in ABC and a M1 in ABC, right? So this is how memory gets allocated in this. Next, here if I write this also, then you will not get any difference. In this case, this use is with the inner classes. You please watch my inner classes video and to understand this in better way, right? So this is the another use of this keyword, and that is to call a method from another method with this keyword. And remember that it is always from a instance context. You cannot do that from a static context. right? So the next use of this keyword we're going to see in next tutorial, in the next session. uh, Thanks for watching my video, and please subscribe my channel for more videos.